This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua Barbuda and the rest of the world. Welcome again to another in the series, Mastering Mathematics. It's a program sponsored by the Ministry of Education using its EBE unit, our Center for Mathematics Education and Worry, and ABS Television. Yes, time marches on and it's very close to our examination time. So again, we're going to be focusing on our performance and the topic factorization. Now last week, aunties, grannies, uncles, everybody, I did something. I rushed you straight into an examination paper without having taught you some of the factorization principles. So you know what's going to happen when I do something like that. Yes, I must not lose any of my students. So we are going to step back. We will just remind you that we're saying that factorization, we can classify them into several topics, okay? We have those that we would say would follow the rules for distributive law, and this is the one that you're accustomed with. So we're going to give you some of this first, and then I'm going to take you into at least two of the factorizations that would have been following the principle for quadratic equations, all right? And then tomorrow we can go back to our examination questions for our question number 2 to see exactly what some of those things are. So, not talking without any further ado, we're going to get straight into our stuff. And please remember, don't forget that students, you can go using your tablet and the things are right here. All the series are right here, okay? So you don't have to wait on Miss Weston and say, oh, I wonder when she's going to do trigonometry. Oh, I wonder when she's going to do geometry, all right? That is for another audience and to make certain that we actually put in the stuff. But you have everything. Keep on going, okay? YouTube / Mastering Mathematics and you'll get it. Facebook has it too. And remember, we gave you another CaribbeanOERU.org and everything is there. So we get straight into our business, and Barbuda especially, please make use of your tablets. I'm right on here. There's so many things to do, but I do promise that I should be over for the month of April so that we can go through, and I will be there physically to take you through for your examinations, just giving you tips. Because we know most of our examinations are passed because of our strategy that we're going to use. Right, so this is not new. This is what I'm saying. When we get something like asking you to factorize 4x squared plus 4y, and we have to factorize that, we know right away we're putting up our brackets. Okay, we're looking for common terms or our common factors, and we can see right away that our eyes will tell us that the 4, if we take a 4 outside, once the 4 has gone, we're left inside with just x plus y, and that is the answer. That is as simple as we can get it. From that one we would go to another one, and all of these we're saying would be following our distributive law, okay? So if we had this one, which is 3x squared, and it's minus 6x, and we were asked to factorize that, what would we be doing? So let me take this off so that nobody thinks that this is related to what I'm saying here right now. 3x squared minus 6x, and we have to factorize it. So what are we doing? We're putting up our brackets, all right? This is one term, this is another term. And we're looking for our common factors. And what did we say? We'd look at our numbers first. Are there factors that are common to the numbers? And we can look and see, yes, we can take out the 3. Having taken out the 3 here, we have inside, what would we be left with here? Because we actually say we can split our 6 into 3 times 2. This would be a 3 times 1. So once we remove the 3's, we see right away that here we'd be left with a 1. but you know we don't write 1, so we're writing back our x squared, and it's minus, and it is 2x. Okay, and we're looking again and say, do they have anything in common? And we know that x squared means x times x, and we see an x in the second term, so we know we can take an x outside, and it goes out to meet the 3, so it would be 3, and it's now times this x, and inside we're left with x, because x squared is x times x, and it's minus 2 times x. So if we have 2 times x, once we remove the x's, you see what we are left with, okay? So that for our third line, we would have been writing 3x, and it's times, and it's just x minus, and it is just 2, okay? And it's x minus 2, and that is the answer. All right, and all of these we are saying it follows the principle of the distributive law. Let us go further when we get something where we have 4 terms. Now I want you to start thinking, count how many terms they are giving you, and you will see right away. So if it's 2, it's 1 bracket. We have 3, it is still 1 bracket. If we have 4, right, we're pairing the terms. If we have 4, we're pairing the terms. So that when you have, and they're asking you to factorize ax, and it is plus by, and it is plus bx, and it is plus ay, what we would be doing is you putting them in groups of 2s. So you put your bracket here, a bracket here, bracket here, and a bracket here. All right, so that is what we're doing, and then we start examining each of those brackets. Do they have anything in common? And we are looking, and for this particular one, we're saying, oh no, we can't put our brackets like that, because there wouldn't be anything in common. So what do we have to do? So I'm taking away the brackets, and what are we saying? We are now going to group the terms that share something in common. Okay? So don't forget that this was bx. Notice what I did a while ago would not have given me things that have terms in common. So we have to go looking for them. And it is here, so I would have been writing ax, and it is plus by, and it is plus bx, okay, because it's the x's, plus bx, and I can put this in a bracket, and I have plus, and I can write ay, and it is plus by. So notice that I have looked for things, and I'm grouping them according to the things that they have in common. Now, unlike what was done here, I will tell you that in your examination room, how the terms are given to you, you hardly have to sort them. That is how CXC helps you. All right, so when we work in the examination paper, you're going to see that. But here in our practicing session, I had written them so that we did a sorting, so that we can say, make certain that they are common things, the things that they have in common, that they are together. And we can look right away and see that the x's are here. So we can take out an x, and taking out an x, in front of the bracket we're going to have a plus b, and it is plus, take out a y, and inside we're going to be left with a plus b. Okay? And then what do we notice? Can you see? We're saying x times a plus b, y times a plus b. So what are we saying? A plus b is a common term too. So once we would have done that, taking away a plus b, then what we're left, a plus b, what we're left with here is just x plus y, and we put them in a bracket, and that is the answer. All right, so for 4 terms we should be getting 2 brackets. And let us look at the last one with this type now. So this is our rule, and it is following the distributive law. Okay, now just giving you just a little time there to say you're copying down, because you may say, oh, my Miss Western, no erase that yet because I don't have everything. Now look at what we have here. We have this one, which is now saying it is a squared c squared, and it is plus acd, and it is plus acd plus d squared. Again, we would be grouping in groups of 2s, okay, in groups of 2s, and then we would be putting in our brackets. So we have a bracket here, bracket here, bracket here, and a bracket here. All right, and then we can take out, what can we take out from our first bracket? Yes, we can take out AC. So taking out AC, inside here we'll be left with one of the A's, one of the C's, and it is plus D. All right, just look again and see. We had said what is common, and it is AC, and then it is plus, and we can look at a D. Okay, we can take out a D, and inside we'd be left with AC, and it is plus D. And then again we can say, what are we saying? We are saying AC, open bracket, AC plus D AC plus D. Okay, so we know we are saying this and that common, so we can take it out, AC plus D, and then inside we'd still be left with AC plus D. And then right away, our smart students or people who are looking and seeing, as long as we have the 2 terms are the same, it would have been the same thing as if we had A times A. You would have been saying that that is A squared. So when we have AC plus D times AC plus D, it is indeed AC plus D all squared, just because of this principle. All right, because that's to the 1, that's to 1, and when we add, when we multiply, we add the index. So I have given you, walk in your spirit again, walk you through what you know in terms of your distributive law for factorization, sending you on a break now to cool off, because when we come back, I'm going to introduce you to the factorization for the quadratic equation, this time where the x squared term does not have a coefficient. Okay, so take your break and we'll be right back.
Don't look on what I cannot do. Focus on what I can do. I may not say what I do, but I can hear and feel it as strongly.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So let us teach them the way that they learn and help them to achieve their full potential.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Right, so you had your break and we're back because we are working. Don't have time to talk, all right? Business now, crunch time. So we are now looking for factorization of our quadratic equation, and this is the one where the equation without the coefficient, okay, without the coefficient of the x squared term. That's the one we're looking at. So we have the first one here. What would we do if we had to factorize this? And listen to how simple this is. We are going to look, and first of all we're putting up two brackets, all right? Where we have our x squared term, we know that x squared means x times x. So we're going to put each of these x's in one of the brackets, all right? The other term that we have to use is our constant term, which in this case is our 6. We have to look for the two factors of 6 when we can multiply together, and when we add we can get the middle term, the coefficient of the middle term. So what does that mean? It means we can say, let's give me 6. I can say 6 times 1, and I can say 2 times 3. Okay? What am I looking for? I am looking for -5. Can we get -5 out of any of these factors? And we can look and see, if I made the 6 a -6, I would get a -5. If I made this 2 -2 and -3, and then and here, to get the 5, we're not multiplying this time, we're adding, okay? So I would say -6 plus 1 would have given me my -5, okay? So when we add or subtract the two factors, okay, of 6, if we get back the middle term, then they're possible candidates for our brackets. However, listen carefully. When we use the factors and we add them or subtract them to get the middle term, when we go back and multiply them, we must get what we started with, which is the +6, okay? And look what is happening here. When we have -6 plus 1, surely we can get -5. It means that we had to make the 6 a negative number. So when we multiply -6 times +1, we are getting a -6, which is not what we started with. So we can't use it, all right? So it is not sufficient just to get the middle coefficient. We also have to get the product must give us back the number we started with, or else it is not a candidate. So the factors must fulfill two jobs, okay? They must give us back the number we started with, and when we add or subtract them, we must get the middle term, not 1 This only satisfied one condition, so thank you very much, but no, we cannot use it. Okay, so we're left then with our only alternative. So let us see why that can work. We have -2 and it is plus -3. We have made them negative numbers, and that would give me a -5. Okay, so we're getting our middle term. When we now step back here and we do our multiplication, what are we going to get? Because we're looking for our +6. Is that going to give us our +6? Let us see, because we know our rules, right? So in your head, you're saying negative times negative equal positive. So you don't even go any further, because you say, isn't that what I have here? A negative times a negative will give me a positive. And 2 times 3 is 6. So what am I going to get? Yes, my +6. So these are the factors that we can use. And because in this case, the coefficient of the x squared term is 1, so you see I have to go back to tell you something that I said. The coefficient of the x squared term is 1. We can fit these numbers in either of the brackets. So we can choose to write -2, -3. Or if someone had written that it is x and it is -3 times x minus 2, that is correct. Because again, what do we know? We know the law of commutative, right? The commutative law says the order in which we multiply or add numbers does not matter. And that is our answer. Ooh, let us step back here, because again, what did we say? In mathematics, we have got to be precise. We have got to give you the right definitions. I said a while ago, we were doing quadratic equation without coefficient of the x squared term. That's a wrong statement to make. It should be saying coefficient where the x squared term is 1. Because there is indeed a coefficient, all right? So that is why I'm saying to you, you do the things for yourself. Don't listen to the textbooks when they say something like that, because there is a coefficient. The coefficient is 1. So we are showing you first factorized quadratic equation, the factorization, where the coefficient of the x squared term is equal to 1. That is what we're doing. It has a coefficient, but that coefficient is 1. And teachers, this is where the delight comes from. You're doing something. It does not mean because the textbooks are telling us without a coefficient that they are correct, okay? And that is what we're talking about. Mathematics, again, we say is a discovery subject. And you will feel good when you can get into your classroom and you're into your subject and you can see statements that does not conform to what definitions are all about. We do have a coefficient for the x squared terms, but those coefficients would be equal to 1. So the factorization that we have been showing and want you to learn is where the coefficient of the x squared term is equal to 1. Right, so we have showed you today the first of how this is done. We have only just started. We are coming back tomorrow because guess what? Our time has gone. So just where we left off tonight, we're just asking you to go and take your little 6 hours sleep, eat your breakfast, eat your lunch, and just sit down and wait for mastering mathematics, because we are ready to go, because we're taking you through to make certain you see it. Factorization, where the coefficient of the x squared term is equal to 1. And then I will give you when the coefficient of the x squared term is not equal to 1. All right, so we're getting into our factorization. We're not going to rush them because this is the bone of factorization. So until we come tomorrow, this is Karen Weston, and with me, yes, my only Jetta is here today. He does not have to talk because I want to make certain that I ram home this point and this concept. So there's no time. I don't want anybody in my classroom, okay? I want to make certain that I tell you the right thing and that you get it, okay? when we're working the exam questions, they can come and talk, but not right now, because I have to make certain that precision is there in terms of what you're learning. Enjoy your evening and see you again tomorrow.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.